we can start now. So today, first we will talk about prime numbers and composite numbers. Okay. Prime numbers and composite numbers. So I'll give you two examples here. So first, let us take about 40, and also we'll take about, let's say, 11. Okay. So initially, before you are going into this prime and composite numbers, you should know what factors are. Like, let us take the case of 40 here. So 40 I can write in different ways as the multiple of two numbers. Like 40 I can write it as 40 into 1, right? Then I can also write it as 2 into 20. I can write it as 4 into 10. I can write it as 5 into 8. So all these different ways I can write 40. So that means this, when it comes to 40, 40 is a factor of 40, 1 is a factor of 40, then 2 is a factor of 40, 20 is a factor of 40, right? 4 is a factor of 40, 10 is a factor of 40, 5 is a factor of 40, 8 is a factor of 40. So 40 has multiple factors. Factors means that you can divide that number exactly by that number. Like if I take 40 divided by 10, I can exactly divide. 40 divided by 10 is 4. So I can exactly divide 40 by 10. That means 10 is a factor of 40. So what are the factors of 40? 1 is a factor of 40, 2 is a factor of 40, 4 is a factor of 40, 5 is a factor of 40, 8 is there, 10 is there, then 20 is there, 40 is there. All these are factors of 40. Now, the same way, when I ask you about 11, what is your answer? What are the factors of 11? What are the factors of 11? Yes, 11 I can only write as 1 into 11. In no other ways I can write 11. Okay, as the multiple of two numbers. So for 11, you have got only 1 and 11 as factors. So here 11 is a prime number. So what is a prime number? A prime number is a number which has only got 1 and that number as factors. So for here, for 11, only 1 and that number, which is 11, is only the factor. But for 40, you have got many factors. So 40 is known as composite number. So this is the difference between prime number and composite number. So a prime number means it has only got 1 and that number as factor. And composite number means you have got multiple factors. So this is the difference between prime number and composite number. So now, if I ask you what about 0? So 0, it is not a prime number and not a composite number. So 0 is not a prime number, not a composite number. What about 1? Whether 1 is a composite number or a prime number? What do you think? What do you think? 1 is also not a prime number. Yeah, 1 is also not a prime number and not a composite number. So 0 and 1, they are not a prime number, not a composite number. So prime numbers start from 2. So 2, I can only write it as 1 into 2. There is no other way I can write 2 as a multiple of two numbers. So 2 has got only 1 and that number 2 as the factor. So 2 is a prime number. Then when it comes to 3 also I can write only as 1 into 3. No other way I can write 3. So 3 also is a prime number. So 2, 3 are prime numbers. So here the thing is, you need to, when you get a number, I'm not saying about big numbers, but at least when you get a number which is less than 100, you should know whether it's a prime number or not. So I'll teach you a simpler way in which you can identify whether it's a prime number or not. So before that, I'll just show you the different prime numbers. Okay, so 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, then 11 is a prime number, 13 is a prime number, 17 is a prime number, 19 is a prime number, and so on. So this is going in this way. So how can you identify, or how can you say fast whether a number is a prime number or not? If I ask you, tell me the prime numbers below 100. So how can you do that? Very easily. I'll show you. So what you need to do is, you need to write the multiples of 6. That is 6. That is a multiple of 6. Then next multiple is 12. Next multiple is 18. Next multiple is 24. Then we have 30. Then we have 36. You have 42. You have 48, you have 54, 60, 66, 72, 78, 84, 90, 96. So these are different multiples of 6. So first write the multiples of 6. Then you write the numbers just before and just after these numbers. For example, when you consider 6, the number just before 6 is 5. And the number just after 6 is 7. The number just before 12 is 11, just after 12 is 13. The number just before 18, 17, and 19. Here it is 23, 25. Here it is 29, 31. Here it is 35. You have 37. Here it is 41, 43. Then 47, 49. You have 53. 55, second, 60. So you have 59, 61. You have 65, 67, 71, 73, 77, 79. Then 84, 90, 96. So you have 83, 85. You have 89. 91, you have 95, 96, 97. So these are the two numbers just before and after the multiples of 6. So I'm talking about numbers less than 100. This is same. This is actually this is all applicable for the numbers above 100 also. So even if you want to find a prime number above 100, then you can just again write the multiples of 6 and do it. So now here I wrote many numbers, right? So here you know obviously that some numbers are not prime number. For example, when you take 25, you know 25 is not a prime number because 25 is a multiple of 5. It has got 5 as factor other than 1 and 25. So 25 you can cancel out. Then next 35. 35 also 5 is a factor, 7 is a factor. So you can cancel out 35. Then you can cancel out 49 also because 49 is 7 into 7. So any other number you can cancel like this. Any other number is there. So then you need to cancel out all the numbers which obviously you know it's not a prime number. So here again, if you see 55, 55 is a multiple of 5. You can cancel it out. Then 65, 65 is a multiple of 5. You can cancel it out. Then you have 85, which is a multiple of 5. You can cancel it out. You have 95, which is a multiple of 5. You can cancel it out. So just cancel out all these multiples of 5. Okay. So now what you are left with is 5. You know 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 is a prime number. 17 is a prime number. 19 is a prime number. 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73. 77 is not a prime number, so you need to cancel it out. Then 79, because 77, you know it's a multiple of 7. Then 83, 89, 97. Now what about 91? So below 100, what we have done is below 100 we have written the multiples of 6. Then you have written the numbers just before that number and just after that number. Then what you did, you cancel out all the obvious numbers. So obvious numbers which are not prime numbers. So that was easy to cancel out. And the only number which is not that easy to cancel out here is 91. 91 is actually not a prime number because 91 you can write it is actually 7 into 13. So remember this one. So below 100, if you are doing in this way, all the numbers, if you write the numbers which is just before and just after the multiple of 6, all the numbers which are actually obviously not prime, you can easily cancel it out other than 91, because 91, many people, when you just see 91, you will feel that it is a prime number. But 91 is actually 7 into 13 and it's not a prime number. So you can see 91 a lot of times in the question papers, because 91 is a special number. It's a prime number and it is the most careless prime number, because students normally when you see 91, you will feel that it's a prime number. And UPSC is also, that's why UPSC also uses 91 a lot. And I'll show you during the course, I'll show you where UPSC uses this 91. And in 2023 paper, there was one question in which you need to odd one out. Odd one out question was there, in which you need to find out which is not a prime number, and there you needed to find out 91. If you know 91 is not a prime number, you can answer that question. So remember, 91 is not a prime number, and all other numbers that I circled here is a prime number. So in this way, you can find out a prime number. So remember that all the prime numbers except 2 and 3, because we started from 5, right? Here you are starting from 5. So all the prime numbers greater than 2 and 3, other than 2 and 3, it will be either 1 less than a multiple of 6, or it will be 1 greater than a multiple of 6. So if I give you a number which is not closer, or which is not 1 less than a multiple of 6, or which is not 1 greater than a multiple of 6, then it will not be a prime number at all. You understood? You understood? So all the prime numbers except 2 and 3, you can write it as, actually you can write it as 6k plus 1 or 6k minus 1. So 6k plus 1 means what? 6k is a multiple of 6. Then add 1. So that is 1 greater than a multiple of 6. And this is 1 less than a multiple of 6. So for example, if I give value for k as like 1, if I give value of k as 1, that will become 6 into 1 plus 1. What you will get? You will get 7. Now here what you will get? 6 into 1 minus 1. You will get 6 into 1 minus 1. You will get 5. So 5 and 7 are prime numbers. Now if I give value of 2 to k, it will be 6 into 2 plus 1. That is 13. And 6 into 2 minus 1, which is 11. So 11 is a prime number. 13 is a prime number. So all the prime numbers other than 2 and 3, you can write it as either 6k plus 1 or you can write it as 6k minus 1. You understood? But it doesn't mean that all the numbers which you can write like this is a prime number. For example, if I give k is equal to 4, what happens? 6 into 4 plus 1. This is 25. Then 6 into 4 minus 1 is 23. Here 23 is a prime number, but 25 is not a prime number. Okay, so all the prime numbers, you can write it as 6k plus 1 or 6k minus 1, but it doesn't 100% means that if a number you can write like this, it's a prime number. It's not the other way around. You understood this? So you don't need to worry about this much. Just understand that if you want to identify the prime numbers less than 100, then it will be easy for you to do like this. You can write the multiple of 6 and then the numbers just before that or just after that, it will be a prime number. Not always it's a prime number, but most of the cases it will be a prime number. And other numbers which is not a prime number, you can obviously understood, like 25, you know it's not a prime number. So just cancel it out. And I already told you that the only number where you will get confusion is 91. So 91 is not a prime number because it is 7 into 13. So remember this one. So you understood the concept of prime number and composite number, and UPSC will ask questions based on this concept, prime number and composite number, and we'll be doing that. We'll be seeing UPSC questions also in the later stage of the class. Okay. Now, just one more thing. So I'll ask you one thing. What is the largest 2-digit prime number? What is the largest 2-digit prime number? So from here, you can identify it is 97. So why I am giving you these things? Because normally questions will not be about large prime numbers. it will be prime number. The questions will be based on prime numbers less than 100. Because when it is a large number, if I ask you about 1009, whether it's a prime number or not, it will be very difficult for you to find out. So normally questions will come about the prime numbers which is less than 100. But just remember these things. The largest two-digit prime number is 97. Then smallest three-digit prime number. Smallest three-digit prime number is actually 101. 101 is also a prime number. Now, largest three-digit prime number is 997 and smallest four-digit prime number is 1009. So if you can remember these things, it will be good, because sometimes in other question papers, in other exams, maybe you will get questions from these things. Because these are like important prime numbers, largest two-digit or smallest three-digit prime number, like that, a little bit more important. So you just learn these numbers and understand that these are prime numbers, and also you have to identify the prime numbers before 100, less than 100. So I already told you a trick to identify the prime numbers which is less than 100. So is this okay with you, the concept of prime numbers and composite numbers? Or any doubts are there, you can ask. Okay. Okay. So now actually yesterday we ended with fractions, right? I told you what is like a proper fraction, what is improper fraction, and what is mixed fraction. And I also told you how you can convert an improper fraction to mixed fraction, and also how you can convert a mixed fraction to improper fraction. So that we have learned yesterday. Now, one important thing, another thing that you need to understand is actually the operations on fractions. That means how you can add fractions, how you can subtract fractions, how you can multiply fractions and all. So I'll give you some examples. So let's say you need to add 1 by 4 plus 1 by 3. So 1 by 4 is a fraction, which is a proper fraction, and 1 by 3 is also a proper fraction. So you need to add 1 by 4 plus 1 by 3. So how you need to do is, you can cross multiply here. That means here you do 1 into 3 plus 1 into 4 divided by, you need to multiply these denominators, that is 3 into 4. So what you need to do, when you need to add two fractions, you have to first cross multiply like this, that is 1 into 3 plus 1 into 4, then divided by 4 into 3. So you will get 1 into 3 is 3, 1 into 4 is 4, so total 7 by 12. So this will be the answer. 1 by 4 plus 1 by 3 will be 7 by 12. Now again, we haven't learned about HCF, LCM and all, that will be learning in the, so you can also use LCM concept here. So I will just show you how it is. Like if I wanted to add 1 by 4 plus like 2 by 6, I need to add 1 by 4 plus 2 by 6, let's say like that. So here what another method you need to do is, you need to make the denominator same. You need to make the denominator same. For example, so there what you need to identify is what is a common multiple of 4 and 6. You know, like 4 multiples of 4 are 4, 8, 4, 8, 12, 16 like that. And multiples of 6 is 6, 12, 18, 24 like that. So here actually you can see that 12 is a common multiple. Actually 12 is the lowest common multiple. That is actually LCM. We'll be talking about LCM later. That's why I'm not using the word LCM. Okay, we'll be learning in the later session. So here you know that 12 is a common multiple of 4 and 6. So I need to make both the denominators here 12. So here if you multiply by 3, it will become 12. Then you need to multiply here also with the 3. Numerator also you need to multiply with 3. Again, here you need to multiply by 2 to make it 12. So in the numerator also you need to multiply by 2 to make it, because if you are multiplying the same number in the numerator and denominator, the fraction will not change. Okay. For example, like you have a fraction 3 by 4. 3 by 4 is a fraction. Now I am multiplying with 2 in the numerator and denominator. It will become 6 by 8. Actually, this fraction 6 by 8 is same as 3 by 4. So if you are multiplying with the same, if you are multiplying with the same quantity in numerator and denominator, you will be getting the same fraction itself. So this 3 by 4 and 6 by 8 are actually same. So that's what we are doing here. So what happens here is 1 into 3 is 3 and 4 into 3 is 12 plus 2 into 2 is 4 and 6 into 2 is 12. So it became like this. That is, here the denominators have become equal. Now, if the denominators are equal, then you can directly add the numerators. For example, here it will become 3 and 4 is there in the numerator. So just add 3 and 4 together and you use 12 as the denominator. So it will become 7 by 12. So here, if the denominators are the same, then you can directly add the numerator. For example, if I am giving you like 5 by 7 plus 3 by 7, already the denominators are actually same. Then you can directly add 5 plus 3 by 7. So that is 8 by 7. But if denominators are different, then you may need to do the cross multiplication, or you can use the LCM method also. This is how you need to add two fractions. And it is same in case of subtraction. For example, if I wanted to subtract 5 by 7 minus 3 by 7, then again here denominator is the same, then you can directly do the subtraction in the numerator. Like you can write it as 5 by 3 minus 7. So it becomes 2 by 7. Or if I wanted to subtract like 1 by 3 minus 1 by 4, here what is there? Here denominators are not same. Then you might need to do the cross multiplication. So it will be like 1 into 4 minus 1 into 3 divided by 3 into 4. So that is 4 minus 3 by 12 or 1 by 12. So this is how you need to do the additions and the subtractions in case of fractions. If denominator is the same, then you can do directly. But if denominators are different, then you need to do the cross multiplication, or you can use LCM. Is it clear? So UPSC will not directly ask to do these calculations in fractions and all, but in some questions, this might come in handy. You may need to do the calculations of fractions. Then only you will come to the answer. It won't be direct questions. I'll show you the questions later. Is it okay? So this is about addition and subtraction in case of fractions. Now, what about multiplication of fractions? Multiplication. That means I need to do 1 by 4 into 2 by 3. So 1 by 4 and 2 by 3 are two fractions. I need to multiply that. So in case of multiplication, you can directly multiply numerator divided by you can directly multiply denominator. So it will become 1 into 2 by 4 into 3. So 1 into 2 is 2. 4 into 3 is 12. So it is 2 by 12. 2 by 12 actually you can make it into a smaller form, because if you see here in the numerator and the denominator, 2 is a common multiple. Right? So you can divide 2 in the numerator and you can also divide by 2 in the denominator. So if you divide by 2 in the numerator, it becomes 1. 12 by 2 is 6. So actually 2 by 12 and 1 by 6 are the same fraction. Normally in the options, you will be getting the smaller, that is the smaller form only. So you need to do the cancellations and you have to come into the smaller form. So 2 by 12 won't be in the option. Only 1 by 6 will be in the option. So you need to do that cancellation to get the smallest form. So this is how you need to do the multiplication. Now what about division? Let's say I need to 1 by 4 divided by 2 by 3. I need to do 1 by 4 divided by 2 by 3. So here what you need to do is, you have to make this division into multiplication. That is, I am changing into 1 by 4 into 1 by 4 to divide. I am changing into 1 by 4 into. Then what you need to do is, you need to make this into reciprocal. Reciprocal means you just need to make it upside down. So 2 by 3 will become into 3 by 2. Okay, 2 by 3 will become 3 by 2. So if you get a division, just make it into multiplication and make the other fraction upside down or make the reciprocal. So this will become 1 into 3 by 4 into 2, that is 3 by 8. I'll give you another example. If you want to divide 2 by 5 divided by like 1 by 4, what you need to do? You have to write 2 by 5, then you need to write multiplication, then you need to take the reciprocal. So it becomes 4 by 1. So it is becoming 2 into 4 by 5 into 1. So that is 8 by 5. So this is actually what the operations on fractions: addition, subtraction, and multiplication and division. So is this okay? So these are the general things which you need to use when some questions come. Okay. So anyone have any doubt, or I need to tell once again? You can just message me. Is it okay? Operations on fractions. Okay, fine. Now, this is important. Okay, this is actually important. Finding the smallest or largest among fractions. So there is a trick for that. So just I am giving you one example here. So I am asking you 2 by 3. I am giving you two fractions, 2 by 3 and 5 by 7. Now I am asking you which is the smallest one. Is it 2 by 3 or 5 by 7? Or I am asking you which is the greatest fraction. Is it 2 by 3 or 5 by 7? So normally what you have to do, you have to do the division, then only you can find out which is the smallest and which is the greatest. So here if a question comes like this, whether you need to identify which is the greatest number among given fractions or the smallest number among given fractions, there is a trick to that. You can actually cross multiply. That is, here you have two fractions like 2 by 3 and 5 by 7. Now you do the cross multiplication. So here you have to write 2 into 7, and here you have to write 5 into 3, like this. So 2 into 7 is 14 and 5 into 3 is 15. Now you know 15 is greater than 14, right? So then 5 by 7 will be the greatest fraction. So 5 by 7 will be greater than 2 by 3. In this way you can do. This is one method. I'll show you two methods. So one is by cross multiplication, you can identify which fraction is greater. And another one is, so this is same question I will take, 2 by 3 and 5 by 7. You need to identify which is the greatest fraction. Just put a 0 here. Just put a 0 in the numerator of both fractions. So 20 by 3, you know it is 6 point something. It is just greater than 6, like 20 by 3, 6 point something, because 3 into 6 is 18. So it is 6 point something. Now 50 by 7 will be 7 point something, right? Because you know 7 into 7 is 49. So it will be 7 point something. So 7 point something is greater than 6 point something, right? So then also 5 by 7 will be the greatest fraction. So in this two way you can do. Okay, in this two way you can do. And sometimes in questions you can mix this also. You can mix both these tricks and use. I will show you that. Okay. For example, you need to tell me which is the greatest fraction. Okay. So I'll give you a question: 3 by 7, 5 by 8, and 2 by 3. So I'm giving you three fractions. You need to identify which is the largest fraction. Just try. Okay, you are saying 2 by 3. Okay, fine. So here I'll first use the first method. Okay, I'll show you how you can do using two different methods. So first method I'm using, like just here I am doing the cross multiplication. So it will come 3 into 8, and here it is coming 5 into 7. So 3 into 8 it is 24, 5 into 7 is 35. So 35 is greater than 24. So this fraction will be greater than this fraction. 5 by 8 is greater than 3 by 7. So you understood 5 by 8 is greater among these two fractions. Now you compare these two fractions. Okay. 5 here it will come in 5 into 3, and here it is coming 2 into 8. So 5 into 3 is 15 and 2 into 8 is 16. So you know 16 is greater than 15. So among these two fractions, this is greater. So in this way, you might need to do two calculations here. In two steps, you can find out that 2 by 3 is the greatest fraction. Now, another method is our second method. So how you can do using second method? Just put a 0 here. 30 by 7, you know it is 4 point something, because 7 into 4 is 28. Now 50 by 8 is will be 6 point something, right? 6 point something, because 8 into 6 is 48, and 20 by 3 is also 6 point something, right? So here you might need to do more calculations, right? Like 50 by 8 is what it will be coming. 50 by 8 is like 6 into 8 is 48, then 2 is the balance. So among 20, it is coming 8 into 2 is 16. So 6.2 will be coming. And here it will be 6.6. Either you can do like this, or if you are getting these two as 6 point something. So both these two fractions you are getting 6 point something. So you need to identify which among this is the greatest. Anyway, this will be the smallest one. Then here you can actually use this cross multiplication. So that's why I told you that you can mix up. So initially you can do using the second method, and then if you can find out two fraction which is the greatest, then there you can use the first method. It will be easy if there are more fractions. I'll give you another example. 2 by 3, 3 by 4, 4 by 5, 5 by 6, and 6 by 7. So try to identify which is the greatest fraction among all these fractions. Okay. Others? I got one answer, which is 6 by 7. Okay. Okay. Actually, here you can mix up our two methods. First, you can do the just add a 0 in all these numbers. Then you do the approximate division. So 20 by 3, you know it is 6 point something. 30 by 4, it will be 7 point something because 4 into 7 is 28. 40 by 5, it is exactly 8, right? 50 by 6 is 8 point something. And 60 by 7 is 7 into 8 is 56. So it is also 8 point something. Now you understood that these are all small. This is both 8 point. So one among 5 by 6 and 6 by 7 will be the greatest one. So then you can do the cross multiplication here. So 5 into 7 is 35 and 6 into 6 is 36. So 36 is the greatest among 35 and 36. So 6 by 7 will be the greatest. So this is why I told you that sometimes if there are many fractions, then it will be easy for you to use both the methods to find out the answer. So 6 by 7 was the greatest here. Now one more thing I will show you here. So our question was 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7. So you can see a pattern here. Like if I am adding 1 here to the both numerator and denominator, it is becoming 3 by 4. Now if I am adding 1 to both numerator and denominator is here, it is becoming 4 by 5. If I am adding 1 to numerator and denominator here, it is becoming 5 by 6. Now again, if I am adding 1 to both numerator and denominator, it is becoming 6 by 7. So if there is a fraction, let's say p by q. P by q is a fraction. Now I am adding a number n, a positive integer n, to both numerator and denominator. You are getting, let's say, another fraction a by b. Then a by b will be always greater than p by q if p by q is a proper fraction. So do you understand what I said? If there is a proper fraction and you are adding the same number, same positive number to the numerator and denominator of that proper fraction, you will get another fraction, right? So that fraction will always be greater than the initial fraction. UPSC has asked question like this. Once UPSC has asked question like this. So I will again tell you one thing. Just write this thing. If a positive integer n is added to both numerator and denominator of a proper fraction. This is important. Okay, proper fraction. Then resulting fraction will be always greater than the initial fraction. So you understood what I said? Is it okay? So if you are adding a positive integer n to the numerator and denominator of a proper fraction, then the resultant fraction will always be greater than the initial fraction. For example, I am taking a fraction 2 by 5. I'm taking 2 by 5. Now you are adding, let's say, 2 to both numerator and denominator. So you are adding 2 to numerator, you are adding 2 to denominator also. So you are getting a fraction 4 by 7. So 4 by 7 will always be greater than 2 by 5. Okay, this is what I meant. And UPSC has asked question once from this concept. And what do you think will happen if this is the case with an improper fraction? Like the same thing, but it is an improper fraction. Improper fraction means numerator is greater than denominator. For example, I am giving you 5 by 2. So 5 by 2 is an improper fraction. I am adding the same positive integer to the numerator and denominator of this improper fraction. So I am adding 2 to numerator and I am also adding 2 to denominator. Then it will become 7 by 4. So your initial fraction was 5 by 2 and now the fraction is 7 by 4. So if it is an improper fraction, then the resulting fraction is less than the initial fraction. That means 5 by 2 will be greater than 7 by 4. Here 4 by 7 was greater than 5 by 2. Sorry, 2 by 5. So you have written a sentence like this, right? If a positive integer n is added to numerator and denominator as a proper fraction, then the resulting fraction will be greater. Now, if the same I am writing for improper fraction, if a positive integer n is added to both numerator and denominator of an improper fraction, then the resulting fraction will always be less than the initial fraction. So just write like that. Sometimes you can easily answer some questions if I give you like this. Do you understood? Anyone has any doubt in that? If you are adding same positive quantity to the numerator and denominator of an improper fraction, then the resulting fraction is less than the original fraction. If it's an improper fraction, it will be less. If it's a proper fraction, it will be greater. Okay, just write that. Now I will give you a question. You have 2 by 3, you have 4 by 5, you have 6 by 7, you have 8 by 9. So which will be the highest? Which will be the highest fraction? Which will be the highest fraction? Yeah, one said 8 by 9. Yeah, 8 by 9 will be the highest fraction. Why? So these are all proper fractions. All are proper fractions. Numerator is less than the denominator. Now if I am adding 2 in this fraction, if I am adding 2 in the numerator and denominator, you are getting this one. If I am adding 2 here, you are getting this one. If I am adding 2 here, you are getting this one. So this will be the highest one. Now same thing if I ask you like this. 3 by 2 is there, 5 by 4 is there, 7 by 6 is there, and 9 by 8 is there. Which will be the highest? Which will be the greatest fraction? Yes, it will be 3 by 2 because the given fractions are improper fractions. Okay, given fractions are improper fractions. Now if I am adding same value 2 to the numerator and denominator. Here I am getting 5 by 4. If I am adding 2 here, I am getting 7 by 6. If I am adding 2 here, I am getting 9 by 8. So it will be decreasing like this. If it's an improper fraction, it will be decreasing. If it's a proper fraction, it will be increasing. So here 8 by 9 was the largest fraction. Here 3 by 2 is the largest fraction. So you understood the difference. Is it okay? Is this okay with you? Okay. So I'll just say one sentence. I'll say one statement. Just say whether it's true or false. So I'm saying if a positive integer n is added to both numerator and denominator of a fraction, then the resulting fraction is always greater than the initial fraction. Is it true or false? I'll say you once again. If a positive integer n is added to the numerator and denominator of a fraction, then the resulting fraction is always less than or always greater than the initial fraction. Why it is false? Because I only told you fraction, I didn't mention whether it is improper fraction or proper fraction. So if it's only fraction, you cannot say anything. It will be false because it could be proper fraction, it could be improper fraction. So if it's an improper fraction, then the resulting fraction will be less than the original fraction. If it's a proper fraction, then the resulting fraction will be greater than the original fraction. So you understood the difference. So if you are adding a number n, a positive number n, then if it's the proper fraction, then it will increase. The resulting fraction will be greater. And if it's improper fraction, then it will reduce. And if I'm only saying fraction, you don't know whether it's improper or proper fraction, then you cannot say anything. Sometimes it may increase, sometimes it may decrease. You understood? So UPSC had asked from this concept. I'll just give you one more question. 4 by 3, 6 by 5, 7 by 6, then 8 by 7. Which will be the greatest one? So others, what do you think the answer is? So given fractions, are they proper or improper? Numerator is greater than the denominator. Then it is improper fractions, right? All these are improper fractions. So here, if I am adding 2 to both numerator and denominator, I am getting this one. Okay. Then this fraction will be greater than this fraction because this is improper fraction. If an improper fraction, we are adding the same quantity, then the resultant fraction will be less. So 6 by 5 is less than 4 by 3. So 4 by 3 actually is greater than 6 by 5. Now, if you compare these two, now here you are adding 1 to both numerator and denominator, you are getting this one. So again, this will be less than this one. Again, you are adding 1 to both numerator and denominator, you are getting this one. Again, it will come like this. Right. So an improper fraction. So it will be decreasing. If it's a proper fraction, it will be increasing. So you understood the difference between improper and proper fraction and how this is changing, how you need to find out the largest and smallest. Or if you have any confusion, you can do the method I was talking about. Like you can just directly do the cross multiplication or something like that. You can do it in both improper and proper fraction. There is no problem. So you understood this. Okay. Okay, if you have any issue, if it's not clear, you just tell me. Okay. Okay, so that was about the fractions. So we'll be doing the questions later. Now, one important thing I will teach you, that is zeros at the end of an expression. So this is important. UPSC has asked questions here also from this concept. So how you can find out the zeros at the end of a number? For example, I'll give you one question like 3 into 10. So you know 3 into 10 is 30. So if I ask you how many zeros are there at the end of 3 into 10, 3 into 10 is 30, there will be 1 zero. Now if I ask you how many zeros are there at the end of 3 into 10 into 10, so it is 3 into 10 into 10 is 300, you will be having 2 zeros. So what is there? If you are multiplying with 110, you are getting 1 zero. If you are multiplying with 210, you will get 2 zeros at the end. Same way, if I am asking you how many zeros will be there at the end of 3 into 5 into 2, how many zeros will be there? Actually, here 5 into 2 is 10. So 3 into 10, it will become 30. Again, 1 0 will be there. Now, if I am asking you how many zeros will be there at the end of 3 into 5 into 2 into 3, 5 into 2, how many zeros will be there at the end? 1 5 into 2 will become 10. Another 5 into 2 will become 10. So you are getting 300. So there will be 2 zeros. So what did you understand from this one? If you have 110, you have 1 0 at the end. Or if you have one pair of 5 and 2, you will get 1 0 at the end. If you have here you have two pairs of 5 into 2. So you are getting 2 zeros at the end. So this is the way you need to find out how many zeros are at the end. The questions may be little more complicated. So you understood what you need to do. Just try to answer this question. 5 into 3 into 10 into 15 into 20 into 2 into 5. So you need to find out how many zeros are at the end of this expression. 5 into 3 into 10 into 15 into 20 into 2 into 5. Just try. Okay. So all are saying for any other answers are there? So here, if you are getting a question like this, you need to actually first split up the question. For example, here 5 you cannot split to anything, so you are writing it as 5 itself. 3 you can write it as 3 itself. Now 10, either you can write it as 5 into 2 or just keep it as 10. Because we know if 10 comes, there will be 1 0 at the end. Or if it's one pair of 5 and 2 also, there will be 1 0 at the end. So either you can make 10 into 5 into 2, there is no difference. Because even if 5 into 2 is there, 1 0 is there. Or if it's 10 also, there is no problem. Now, when it comes to 15, you can split 15 into 5 into 3. Because remember, inside 15, there is 1 5. Okay. Now, 20, you can split it into 2 into 10. Okay. 10 I am keeping like this. Now, there is 1 2 and there is 1 5. So, first you split up like this. Now, you count the number of 10 that is there. So, here you have 1 10, here you have 2 10. So there are 2 10s in this expression. That means there will be 2 zeros at the end. Now you need to also count the number of pairs of 5 and 2. So how many 5 is there? 1 5, here it is 1 5, here it is 2 5, and you have 3 5. So 5 you have got 3 5. Now, so how many 2 is there? You have 1 2 here, you have 2 2 here. So you have total 2 2s. So how many pairs of 5 and 2 will be there? You have like 3 5, and you have 2 2s. So one pair will come like this, second pair will come like this, and third there is no pair. So one pair of 5 by 2 means 1 0 at the end. This pair of 5 by 2 means again one more 0 at the end. So how many zeros will be there at the end? 4 zeros will be there because there are 2 10s and then 2 pairs of 5 and 2. Okay, so in this way you can find out, or you can do like you can change 10 into 5 into 2 also. This 10 also you may change into 5 into 2. Then the pair of 5 and 2 will increase. Again, you will get there are 4 pairs of 5 and 2. That means 4 zeros at the end. So you can do both ways. This was a little bit easier question, and I'll give you one more question now. 5 into 10 into 15 into 20 into 25 into 30 into 35 into 40 into 45 into 50 into 55 into 60. So how many zeros are at the end of this expression? I think this was asked in UPSC. This is the previous year question. Okay. Even if it's wrong, it's okay. Just try to answer. If you are getting the answer, you just put in the chat box. Okay. Okay. So all of you are saying 10. Okay. So now let us see what is the answer. So here again we have to split this out. So 5 I am writing it as 5 itself. 10 I am writing it as 10 itself. 15 I have to write it as 5 into 3. Now 20 I can write it as 2 into 10. 25 I need to write it as 5 into 5. 30 I can write it as 3 into 10. 35 I can write it as 5 into 7. 40 how I need to write? If you are writing as 40 into 10, it is wrong. You have to split this 4 again, because 4 is actually 2 into 2. Now what we are counting to find out the number of zeros? You are counting either 10 or pairs of 5 and 2. So number of 5 is important, number of 2 is important. All other numbers, it doesn't matter. But for 5 and 2, you have to do it exactly. So 4, actually, you can write it as 2 into 2. And there are 2 2's inside 4. So 4, you need to split it again into 2 into 2. That is very important. Now 45, you can write it as 9 into 5. If you want, you can write 9 as 3 into 3, but it doesn't matter. Why? Because our interest is only 5 and 2 and 10. That should be correct. 9, even if you don't split it into 3 into 3, it's okay. Now 50, you can write it as 5 into 10. 55, you can write it as 11 into 5. 60, you need to write it as 6 into 10. Again, 6, you can write it as 3 into 2, because there is one 2 inside of 6. So you need to write it as 3 into 2. Now that's it, right? So this is our split version. Now we need to find how many 10 is there. So there is 1 10, 2 10, 3 10, 4 10, 5 10, and 6 10. So there is 6 10. So now we need to find out the number of 5 and 2 in this one. Okay, so there is here 1 5 is there, 2 5 is there, 3 5 is there, 4 5 is there, 5 5 is there, 6 5, 7 5, 8 5. So 8 5 are there, 2 1, 2 3, and 4 2's are there. So how many pair of 5 and 2 will be there? Always take the lesser value, because there are 8 5's here and only 4 2's are there. So when we are counting the pairs, it will be only 4, right? So total there will be 10 zeros. 6 10's are there and 4 pairs of 5 and 2 are there. Now you first count the number of 10's, right? Now you need to count the number of pairs of 5 and 2. So I already told you that whichever is lesser, you count that. Because 5, if there are hundreds of 5, you have like 100 5's, but only 2 2's are there, means the pair will be only 2. Then you don't need to count the number of 5. You only need to count the number of 2, whichever is smaller. So when you see this question itself, you can see that there will be so many 5's, because all the numbers given are multiples of 5, right? All the numbers are 5 into 10. So there will be so many 5's. So you don't need to count 5. First you count the number of 10, then you count the number of 2 only, because 2 is less here. So that will be the number of pairs of 5 and 2 here, right? So you just need to count the number of 2. You don't need to count the number of 5. Don't waste your time. So here it will be 10. So now I'll give you another example. Let's say 20 factorial. You need to find out the number of zeros at the end of 20 factorial. So what do you mean by factorial? What is 5 factorial? 5 factorial means 1 into 2 into 3 into 4 into 5. You need to multiply from 1 till 5. What is 10 factorial? It means 1 into 2 into 3 into 4 into 5 into, like that, you need to multiply till 10. So what will be 20 factorial? 20 factorial means This is equal to 1 into 2 into 3 into 4 into like that. You need to multiply till 20. Okay. So try. There is actually an easier way, but you first try. Then I'll show you how you can do it easily. So you need to find out the number of zeros at the end of 20 factorial. Okay. Okay, just let me ask you a question. That 20 factorial means 1 into 2 into 3 into till 20, right? So we need to find out, we need to count the number of 5 and 2. Fine. Even 10 is actually 10 means it is 5 into 2. So if you are splitting 10 into 5 into 2 means you need to count the pairs of 5 and 2. Fine. So here in this question in 20 factorial, uh, what do you think? 2 is more or 5 is more? Which number you will be getting more? The number of 2s or number of 5s? Yes, 2 will be more. Why? Because there are many numbers here which has 2. Like 2, 4, 6, 8. 8 has 3 2s. 8 is 2 into 2 into 2. So 10, 12, 14, 16. All these numbers have 2. Right? So 2 will be more. Many numbers are there which is having 2. But what about 5? 5 is very less. 5 will be only in 5, 10, 15, 20 like that. Right? So you just need to count the number of 5s here. I already told you that if there are 100 2s and if you have only like 4 5s, when it comes to pair of 2 and 5, you just need to take the smaller number. So 4 will be the answer when it comes to pairs of 5 and 2. So here you understood that there are so many 2s in this question. So you just count 5. And you know that 5 is only in 5, 10, 15 and 20. It's still 20, right? So 5, 10, 15 and 20 means 4 5s are there. There is 1 5 here, 1 5 here, 1 5 here, 1 5 here. That means 4 will be the answer. Or you can do what? You just need to do, you need to find out the number of 5s inside this 20 factorial, right? So you just need to do 20 by 5. So 4 multiples of 5 will be inside 20. That's it. So the answer will be 4. Now I'll give you another example. Let's say 30 factorial. Find out the number of zeros at the end of 30 factorial. What will be the answer? Okay. Let it be wrong. You just try to answer whatever you are thinking. Okay. So you said 7 and 6 also you are saying. Okay. Let's see which one is the right answer. Others, what about others? What do you think? Okay. 7. So you are telling 7 and 6 also. So let's see why you are getting this wrong. I mean, why there are multiple answers now. So I already told you that we here in 30 factorial, there will be many numbers which is having 2. 2 is there, 4 is there, 6, 8, 10, all these numbers are having 2. So there will be so many number of 2. So we just need to count 5, right? We just need to count 5. So in order to count 5, I already told you what you need to do. Just 30 by 5. So there will be 6 multiples of 5 inside 30 factorial. But 6 is not the right answer. Why? Because which are these 6 multiples? Which are these 6 multiples? Like 5, 10, 15, 20, 25, 30. So these are the 6 multiples of 5 which is coming inside 30 factorial. But when it comes to 25, 25 means 5 into 5. So there are 2 5s inside 25. So you need to count 25 as 2 because there are 2 5s. So total there will be 7 5s. That means 7 pairs of 5 and 2. That means there will be 7 zeros at the end. So this carelessness, it might happen to you. Okay. So remember this one. Now I'll give you another example here. What about 60 factorial? What about 60 factorial? So how many zeros are at the end of 60 factorial? Okay. What about others? Okay, you're saying 13, 14, 15. Okay, here also in 60 factorial, there will be many 2's. Right? So many multiples of 2's are there. So you just need to count 5. So for counting 5, I already told you what you need to do. You just need to find out the number of multiples of 5 in 60 factorial. So you just need to do 60 by 5. 60 by 5 is 12. So you will get 12 multiples of 5 are there inside 60. So what are these 12 multiples? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So these are the 12 multiples of 5, which is inside 60 factorial. Now, when it comes to 25, it is 5 into 5. So you need to count 25 as 2 because there are 2 5s. Now, when it comes to 50 also, what it is? 50 means 5 into 10. 10 means 5 into 2. So 50 is 5 into 5 into 2. So 50 also you need to count it as 2. Right? So what here you should understand that multiples of 25. 50 is a multiple of 25. So there will be two 5s in it. So multiples of 25 you need to count it as 2. So here what will be the answer? 12 multiples are there. Now 25, you only counted 1 inside this 12. So you need to count one more. And 50 also you need to count one more. So 14 will be the right answer. Okay, 14 will be the right answer. So there is a trick here for you to easily find out. What you need to do is, you just divide 60 by 5, you will get 12. So you understood that there are 12 multiples of 5 inside 60 factorial. Now you divide 60 by 25. to identify how many multiples of 25 are there inside 50. So you will get 2 point something, right? So just take it as 2. That means 2 multiples of 25 are there in 60 factorial. So just add this one. 12 plus 2, it is 14. That's it. Okay. Now if I ask you, same before also, if it's 30 factorial, just divide 30 by 5. You understood that there are 6 multiples of 5 inside 30 factorial. Now just divide 30 by 25. It means 1 point something. So 1 multiple of 25 will be there inside 30. So just add this one. You will get 7. So similarly, I'll give you another example here. Let's say 80 factorial. What will be the answer? Tell me. So how many zeros are there at the end of 80 factorial? Yeah. Yeah, what you need to do, you just divide 80 by 5. Just do the division. If you cannot do it fast, you just do the division. You will get 60. So 80 by 5 is 60. And now you need to find out how many multiples of 25 are there in 80. So just divide 80 by 25 also. So you will get 3 point something. So 3 multiples of 25 are there. Like 25 is there, 50 is there, 75 is there. These are 3 multiples of 25. Just add these two, your answer will be 90. So this is the way you can easily find out how many zeros are at the end of a factorial. So I'll give you one more example. What about 150 factorial? Right. How many zeros are there at the end of 150 factorial? Everyone try to answer, okay? Okay, everyone is saying 36. Any other answer is there other than 36? Here again, 150 factorial means 1 into 2 into etc. till 150. So you know that there are so many multiples of 2. So you just need to count 5. So just count how many multiples of 5 are there inside 150. That's it, right? So what you need to do, 150 divided by 5, you will get 30. So there are 30 multiples of 5. Again, if we have to divide 150 divided by 25. So 150 divided by 25 is 6. That means there are 6 multiples of 25 inside. So all this will be having 2 5s. So what are these 6 multiples? 25, 50, 75, 100, 125 and 150. But there is an issue here. The answer is not 36. Why? Can anyone tell me what is the problem here? Answer here is not 36. Can anyone identify what is the problem here? Because if you add 30 plus it is 36, fine, but that is not the answer. Why? Anyone? You know, just tell, there is no problem. No one. Yes, there is 37. Answer is 37. Why? That means there is one more 5. So which 5 you missed? No, 100 is okay. 100 means it is actually 25 into 4, right? That is 5 into 5 into 4. So there is only 2 5 in 100. So you have already counted it here. Not 150 also, because 150 is actually what? 150 means 30 into 5. That is 6 into 5 into 5. So there is only 2 5s inside 150. So that also you have counted. It is actually 125. 125 means actually 5 into 5 into 5. Right? Yes, 125. Adira told. Okay. So 125 means 5 into 5 into 5. Right? So there are 3 5s inside 125. So 125 you needed to count as 3. But if you are adding 30 and 6, you are only counting it as 2. Okay. So what you need to do is, if the given factorial is actually greater than 125, then you need to do 150 by 125 also. Because 125 you need to count it as 3. Just like why we are taking 25 here, you need to take 125 also. So 150 by 125 is like 1 point something. So you need to add all these things, 37. So if your number, the given number is greater than 25, you need to divide by 25. If it's greater than 125, you need to add 125 also. Then only you will get the correct answer. So I'll just give you one more question to make you understand this one. What about 300 factorial? How many zeros are at the end of 300 factorial? Just try. Okay. One told 74. Okay. Here what you need to do, the number is actually greater than 125. So you need to first divide 300 by 5 to find out how many multiples of 5 are there. So you will get 50. Okay. Then you need to divide 300 by 25 to find out how many multiples of 25 are there. So what you will get, 300 by 25 is 12. You will get it as 12. Okay. Now, since this number is greater than 125, you need to also divide 300 by 125. So you will get 2 point something, because 125 into 2 is 250. So you will get 2 point something. So you need to add all these things, 60 plus 12 plus 2. So your answer will be 74. So in this way, you need to find it out. So is it okay finding the number of zeros at the end? There are also different model questions are there. I'll be giving in the next class. I'll show you some more things regarding this zeros at the end. So is it okay for everyone finding out the number of zeros at the end? When it comes to factorial also, you need to do like this. So this is the way there will be careless mistakes. Like if it's coming, if the number is greater than 125, then we will make careless mistakes. So that also you need to understand why it is like that. Now, once you understand why it is like that, you just need to do these things. You can just do it as a trick. 300 by 5, 300 by 25, 300 by 125, just add all these things. But you should know why we are doing like this. Okay. So you can stop it for today. So next class won't be a mock class. It will be, so if you are confirming for the classes, you just need to message me. And the class timings also will finalize before Saturday. Okay. After talking with all the confirmed students, I will check regarding the timings, and then we can confirm the timings also from next class. Okay. Okay. So if you need to ask something, you can ask. Otherwise, you can leave.